Well, I'm recording now, but you can always watch the other section. So I apologize for that. I'll post their link as well as this one, so you can choose if you want to watch it at all. Um, I will never know. Let's talk about um, if. Let's talk about if this change. Let's talk about if this changes right here. So Alexa does all this and she comes back with this interval. And I say, okay, that's great, Alexa, but I want a 95% confidence interval. Okay. Well, the first thing Alexa is going to realize is that alpha half is no longer going to be 0.05. It's going to be, and I always mess this up, alpha is going to be 0.05. And so alpha half is going to be 0.025. Okay, because 0.025 here plus 0.025 here will add to 0.5, and that will be the difference between 95 and 100. More importantly, this z-score is not going to be that anymore. If we change this to 95 and all these changes, that's not going to be that. This will actually increase to 1.96. But conceptually, what I want you to think about is when I do that, what happens to these numbers down here? Do they go, does this one get bigger? Does this one get smaller? Or does this one get bigger? Or excuse me, does this one get smaller? And does this get bigger when I go from 90% to 95? Let's think about this. When I go from 90%, my butterfly net is this big, that I'm trying to catch all those possible butterflies, and I want to be 95% confident, I'm actually going to have a bigger butterfly net, which means that my values, this one is going to be larger, this one is going to be smaller. Okay. So that, again, that is a little bit counterintuitive. It took me a long time to get that and for that to make sense to me. Hope is not a plan, but I'm hoping that makes sense to you. So I can never have 100% confidence. And even Batman doesn't have 100% confidence in this context because these tales go on to infinity, regardless of my dad who doesn't believe in infinity, but that's another story that you never want to hear. So I can't be 100% confident because I can't cover every single possibility. It truly is impossible, but I can be 99% confident. And 99% is really the discipline's way of saying, okay, we got to cut this off at a point. And I would argue that beyond that point, what does it really matter? Okay, because technically these are outliers anyway. So what is the takeaway from all this mess? If we increase sample size, our interval is going to become more narrow. That means our lower value is going to become greater, our upper value is going to become less. If we increase confidence, our interval is going to become wider. That means our lower value is going to become less and our upper value is going to become greater, bigger butterfly net. All right, on to, we got two more problems, but essentially it's one because it's the same problem. We're just going to do it two different ways. All right, so another question that's kind of on my mind that we could investigate, and this is a even better example of that bottom half of our opening slide where we're kind of going into unknown territory. We have an idea, we want to collect some data, but we definitely don't know what the population mean is. And in this instance, I'm curious about how much time your college students are spending studying per week now that we've gone to an online classroom in the midst of coronavirus crisis. There, there probably no one knows that, probably because we haven't been in a coronavirus before. So there hasn't been data collected, and we could say, well, students spend this much time studying in online and this much time. But yeah, that's great, but we haven't done this in a coronavirus during a coronavirus outbreak and pandemic. So um, we don't know that, and we want to take a guess of what that interval might look like. So we want to do the same thing here. We want to develop a confidence interval. So I go around and, well, I don't go around because I haven't left my home in a week and a half and I don't plan on it. But through survey, I'd sampled 10 people. Not that there's anything magical about 10 people. That's just kind of what I went with for simplicity. And I get a sample average of 52.7 hours per week. And you may be going, boy, I'm spending a lot more than that. Well, it's just 52.7. It's made up. This time we're going to go for a 99% confidence interval. Okay. So this leads us to a key, you could say crossroad, that we decide whether to do this problem one way or another way. And that is, so we don't know this, but do we know the population standard deviation? Sigma. Go phi sig. Anyway, do we know that? Now, just to be honest, I don't know how we would know the population standard deviation if we didn't know the mean, because you kind of need to know the mean to determine the standard deviation. So why this is even covered in the textbook, I really don't know. The only guess I can make is that maybe there's some expert out there that could give us an idea of how much variation there could be. I guess. And that's kind of the way we're going to roll with that. So let's suppose that we do know the population standard deviation, and we know that that is 4 hours. Okay. And this is, again, I cannot stress this enough. I can go multicolor and stress it more. Check it out. I get better each day. It's the small victories in life. So, but when you're reading these problems, when you're doing these problems, you really got to shake that problem and say, what am I looking at, and see, I'm trying to determine a population mean or confidence interval. That, so I shake it some more. Is there a population standard deviation in there? Yes or no? If one doesn't fall out, then I know it's to do it another way that we're going to do here in a second. If one does, we're going to do it the way I'm about to do it. So we know the population standard deviation. So our formula is going to look like this. The mean, the mu for the population, some common themes here that we saw before. We're going to lead with X bar. Plus or minus, that's going to give us an upper and a lower. We're going to have our friend Z in there. And this time it's not as complicated. Z delt is not as complicated, this whole thing. But we're going to park that standard deviation here. And we're going to divide by the square root of the sample. In this case, 99% alpha is 0.1, alpha half is actually, I always mess this up, man. I am sorry. I can say I always mess it up. I shouldn't. I'm embarrassed to even admit that. Turn in my warrior card. 0.01 alpha half is 0.005, but since I have my handy dandy Mike TV table, I know that Z is going to be 2.58. And from here, I just plug in the numbers. Remember, I'm going to do this twice. I can do my upper first. So I have 52.7 plus 2.58 times, take that 4, put that there, square root of 10. That's going to be my upper. My lower is going to be the same thing. The only change is that minus. That's it. So figure out whatever you're calling this, Colin or Connor or Ryan or Ryan Collin or anyway, you get the idea. And carry that down there. Again, let's get into the end zone. So our confidence interval is going to look like population mean right there in the center of attention. Mysterious. We just don't know what it is, but it's less than or equal to something. And if we do this computation, that equals 55.96. And the lower side is 49.3. How do I know this? Because I consulted my chicken. And if I just want to be all pretty, I put this in a nice clean box. And finally, the interpretation, which is the average amount of time that York College students, and we'll just say college students in general, are spending in an online setting on studying per week. Based on these statistics here and a confidence interval that is 99% confidence interval, I believe that the population mean is less than or equal to 55.96 hours a week and greater than or equal to 49.43. Bam. Mic drop. Not really. I guess you can't. I could kind of. Okay. So that's how, if you know the standard deviation of the population, which at this point, you should be thinking, well, what if we don't? So if we don't, I'm going to go to red for if we don't, what changes? Well, first of all, we know that this is going to change. That's going to change. This is still going to be greater than or equal to, sorry. This will be greater than or equal to. So I'm going to have new values there. Okay, that's kind of a no-brainer. This is going to go away, but I'm going to leave my yellow thing here because there's going to be a piece that's going to help me solve this puzzle. But before I get to that, the standard deviation is going to go away because I don't know it. So if it goes away there, it goes away here. N doesn't change, so N will stay. Something else might change. So let's go back up here and see. So if I don't know the standard deviation of the population, which most of the time I don't think you will, then we're going to go with the standard deviation of the sample, which we write, remember our back tattoo, is S. Now, in this instance, this example, I'm going to say it's 6. But you should remember the way that we get the sample standard deviation is the same way we get any standard deviation. If we have the values that comprise this sample average, we take the standard deviation of those values, or it's given to you. So that 6 is going to go here in the form of S and here in the form of 6. Cool. Here's the biggest thing. If I don't know the population standard deviation, bye-bye Z. Bye-bye Z value. Bye-bye Z score. I still need to know alpha and alpha half, but I can't use the Z table anymore. Bye-bye Mike TV table. This is the time when I can't use the Mike TV table. I just got to let it go. And I'm not a Frozen fan, so I'm definitely not going to bust out with that one. What I am going to bust out with is a T distribution. So let's go with Sammy Hagar red. So I'm just going to put T right here for now to get us thinking about the T distribution. Now, I'm not going to go on a big philosophical thing or academic thing about the T distribution. The bottom line is when we don't know the standard deviation of the population, we're going to use the T distribution. We have a different table that I'm about to introduce to you. The table that I'm going to show you is already on your canvas this evening. It has some limitations. I will talk about that in the end. If I forget, then Matt, please remind me. And I'm not talking to myself. Okay, first things first, we're going to need two pieces of info before we enter the T table. The first thing is a thing called degrees of freedom. And that simply is n minus 1. So our degrees of freedom is going to be 9 in this instance. Very simple. What are degrees of freedom? I'm just not going to go into all that right now and maybe never, unless you really want me to, and then it'll be for a small fee. So I need to know degrees of freedom, 9. I need to know alpha half, which I have 0.005. With those numbers, let's go to the T table. Now let's see if I can do this without my computer crashing. Get on over here. All right, let me get this bigger. Not big enough. Boom. All right. First things first is to kind of meet this new friend. Whoa, what is this? Well, it's not the T table, or excuse me, it's not the Z table. It's the T, the student's T distribution. So it's going to look different. Don't be scared. Respect the numbers. All will be good. We have the two things we need to rock this thing out. First things first, degrees of freedom. We're going to go up here, up and down the left-hand side, cruise on down till we find that 9 that we identified before we came in. And now we're going to go over here to the right. What we're looking at is the top here for alpha half. Don't get fooled by 0.05. Alpha half is 0.005. So we're going to go all the way over here till those two things intersect. 3.25. Okay. As I hope this is capturing. Let me see here. 3.25. Where those two meet. Okay. So I got to remember that. I know I'm going to forget the 3.25 if I don't watch out. And let me get back out of here to my whiteboard. 3.25. 3.25. 6. See? And I'm going to take that 3.25 and I'm going to put it right down there. I have everything else I need. That doesn't change. Sample mean doesn't change. 3.25, that goes in there. My 6 is my 6. That's new. And same. I'm going to do my computations here. I'm going to do my computations here. I only have to do this one time, the Z delt or Anna Grace or whatever I'm calling that today. And then I just put it here. And then I have my upper up here. and my lower down there. And I'm probably cheating you because I don't have that math, but I think at this point you get the idea. Interpretation, no different. No different. This is a confidence interval based on these statistics and the fact that we do not have a population standard deviation to the 99th percent of confidence. Boom. Of what we think about the population is spending on study time on an online setting during the coronavirus. Okay, real quickly, I want to talk about what we're going to do between now and Thursday. And most importantly, I want to get what's on your mind, questions, things like that. 'Cause I know you got them. Okay. Let's go here. So back to my screen. Chrome is not working that great for me, but let's see if it'll come around. Actually, I had this idea that I was going to put rudders behind me. Thought that might be kind of fun. Um, maybe I will next time. Okay. Here's our canvas for today. This is kind of a second page. Let's back up one. Can I do that? Okay, so here's today. I really just want to, excuse me. It would help if I was in the right class. No, I am. So the agenda is still the same. I apologize. I put 102 crew. It's the same for you all. I'll fix that later. But in the meantime, there's no change. There's some stuff here. The T table that I showed you is right down here. So when you get to a problem where you need to use the T table, that should help you out. And I'll talk about, well, here's the bottom line. That T table has its limitations. Let me see if I can show you real quick. So the problem is it's nice and friendly until you get down to a degree of freedom above 40. See what it does right there? This communist kind of thing. It jumps from 40 to 60 to 80. I have no idea why. Somewhere, some person is having a sick joke laughing. So if you have a problem with the degree of freedom at 41, this table will not help you with that without really turning on that big Batman brain of yours. And feel free to do so. In the meantime, I owe you a couple things. One, is a T table that is better than this if I give you a problem that has a degree of freedom of 40 or more, which you may encounter in Pearson. Again, I apologize. I did not wake up to torture you. The other thing is that the other thing I owe you is where you could find one in your book, regardless of the version that you have. The third thing you could do is GTS this thing. So you could Google it, try to find a T table if you find yourself in that case. When in doubt, if you get in that situation, you're like, I don't have time for this. You know what to do. Call on a fellow warrior or call me and we'll work our way through it. I apologize for that. Back to this. So that's that there today. And down here where I have all this junk, I'll put the video that we're doing right now, as well as the one from the other section, so I can give you what I gypped you on from the beginning. More importantly, what are we going to do between now and Thursday? Well, we're going to do this. So this is the second page for today. You see the date, squad assignments, and a squad drive. So what I want you to do is first open up the squad drive. And the squad drive is essentially a U drive in disguise. It's not going to look like that. T-table is just trying to hog the limelight. It's going to look like this big, nasty picture of Joker because I didn't zoom down. That's what I get. And Joker's laughing somewhere. But Batman will always have the last laugh. So it looks like this, very much like a squad drive, comprehensive in nature. So I want you to think big, used everything you've learned to date in this block, and think about what kind of problem at any given time am I looking at? Am I trying to solve for single value probability? Am I looking at a sample probability given information about the population, or vice versa? I think if we work through this week, you'll get some more reps on what we've learned and then we covered tonight, and we'll be ahead of things and know where we're at heading to an exam next week. Now you see that it says question 1, squad focus. Well, I want you as an individual to do it all by yourself. But what I also want you to do is get up here on Canvas, see what squad I have you organized in. So for example, Eliza's in squad 1. So what's going to happen on Thursday when we do Zoom, I'm going to go, okay, and I could very well say, all right, Eliza, start us off with the squad 1 portion of the squad drive. Now, none of you are on your own. Of course, you always have me, but you always have each other too. So what I want you to do is go up here to the discussions portion, and between now and Thursday, I want you to punch into your squad's discussion. So Eliza could go right here to her squad, and there she is, along with these other folks. And I want each of you to do 2 things: to offer help and to ask for help. You can start with the area that I'm asking your squad to focus on from the squad drive. Okay, so Eliza could say, hey, I think I have an idea how we should solve this. I think this is a single value X probability type of question. And then maybe she says, but I'm not really sure in what values go where. So there she's kind of getting a 2 for 1. All she has to do is break those into 2 different comments. And be honest, folks, I'm not going to be draconian here. I'm really just trying to see that if you ask and offer help to your fellow comrades, and that you can get a little bit of group participation out of here. Am I going to go through and count the number of words you wrote and all that kind of stuff? Quite honestly, no. But like I said, on Thursday, what I'm going to do is pull up our squad drive, and that's how we'll begin. Is I'll say, okay, squad 1, and I'll pick somebody out of that squad 1. So all these folks really got to be ready to talk about the squad 1 focus that's identified on the squad drive, and so on for squad 2. Now, let's say that Tyler's in squad 2. He's looked at the squad focus pit. He's good with that. He's working his way through the squad drive, and he gets down to the squad 4 area, and he's just lost in the sauce. He just doesn't know what to do. He doesn't know how to begin. Hey, we're all warriors, man. We're all in this together. So Tyler can jump on here, the discussion for that. And even though he's not part of the squad, he can read, he can chime in, he can get help from here. So just, hey, Tyler, you're not one of us. That's neat. That's in some other course, not here. So the point is just kind of, without going crazy on this and making this harder than it needs to be, is to leverage our collective strength towards this really comprehensive squad drive. It's kind of a U drive on steroids because it covers this week's work, last week's work, and the work prior to that. So that's what we're looking at between now and Thursday. And with that, I want to get what is on your mind, what you want to talk about, big or small questions you might have.
Dr. Shatskin, I can't open the squad drive. It says access denied.
Ed, it just says that, Cameron, without any.
Yeah, I clicked on it. Access denied. You don't have access to view this resource. We've let your instructor know to review this link as soon as possible.
It says the same things with the agenda, the recognize and prosecute, and the T table in like the other page.
What the hell, man?
Yeah, I can't get in either.
The only thing I was able to download was the PowerPoint.
Same.
I think you guys are ganging up on me, and you just made that up. You're like, hey, let's screw with them, and you say this, and then I'll jump. Now, honestly, I don't. I'm gonna have to fix that right after we get off because I'm looking at everything should be good to go, and I haven't gotten like a nice little Canvas message. So, let's see here. Okay, I got an idea. The Alexa, you said the only thing you could download was the PowerPoint, right?
Yes.
Okay.
Sorry.
You guys just be patient with me. I'm going to try something while you're on here. I think it's because I copied it. So let's do this. And I'm not going to try to fix everything. I'm just going to try to fix one thing. So you couldn't, let me go to the squad drive page. Appreciate you guys bearing with me. I'm just going to put this. I don't know if this is exactly the right file that I want there, but I'm just going to put it there. Okay, on Cameron or anyone else on the squad assignment page, can you download the squad drive now?
Yes.
Okay.
Yeah.
All right. I know what I have to do. I'll have this fixed like within 5 minutes of us finishing tonight. Maybe 6, 7, 8, 9.5. What else? What else on your guys' mind? Big, small? If you have ideas for my backdrop here, you know, I was gonna have like Judas Priest or Brothers or Batman, definitely. Hey, let me talk about the Way of the Warrior project real quick. So I owe you so much, but here's the bottom line on the Way of the Warrior project. I don't want you to stress about it. We're still gonna do a project, but we're not gonna be confined to the construct that I talked about earlier in the course. So if you started with that and you've got data and you're like, dude, I'm like 75% of the way done, well, then drive on with that. But if you're like, I don't have data and I'm not going to go outside to get data because, then I don't want you to do that. I'm not going outside, except to walk around a block. So I'm going to give you some alternatives, at least one, if not two more alternative options for your project. Okay, so I still want you to track on a project. The check is in the mail, but I don't want you to stress that, hey, how am I going to get all this data and do this
What's the
under
date for
these
that project again?
conditions? Say again?
What was the date for that project again?
It is mid-April.
All right.
I want to say it's, I'm guessing, but it's like the 16th. Let's check it out while we're here. In fact, let me do this. April 16th, Tyler, at 7 p.m. 100-point opportunity. So, but I owe you something on that relatively quick so that you can start thinking about it. but I think you all will be okay with the options I give you. Of course, I always think that. What else? Tyler's like got his hood up, so he's ready to do something. I don't know what. Matt looks like he's deep in thought. Colin's like eating a sandwich or something. Alexa's thinking about that lens that she just ordered that's going to get here in a few days. And Noah's like, I really wonder how many people do listen to music while they do. That's kind of interesting.
Are you gonna have more YouTube videos up?
Probably not, unfortunately. You mean like the ones that we had for last week?
Yeah, I really like the sampling one.
Yeah, well, appreciate that. They just they at the risk of sounding like I'm whining, they take me a long time to do.
Yeah.
And I know they don't look like they take me a long time because they're pretty sloppy, but so probably not. I'd love to. I know it's better for you all that you don't have to be tied down to a time. You can watch them at 2 a.m. or whatever, but probably it's going to be more like this. I think we're about ready to bring this thing to a close. Here's what I'm going to do. Two things. One, I want to thank you all sincerely. I'm always impressed by you. I'm definitely impressed by your ability to adjust to this. I suspect that none of you signed up for online education. And if you had your druthers, you wouldn't be doing it this way. But yet you've done it and you continue to do it. I fully respect that it's not easy to do. I'm kind of getting my ass kicked. And I can only imagine that you've got to do this for 5 other people or 4 other people, whatever. So I commend you for that. We can go ahead and drop off. If you want to hang out and ask me a question after everybody's dropped off or whatever, had people do that last session, I'm cool. I will stay until everybody drops off. And I will post this video as well as the one from the other section and give you that link, and I'll fix the documents that need fixing. And so with that, if I don't talk to you, I'll see you on Thursday. Take care.
Have a good night.
Hey, you too. Take care.
Have a good night.
All right, Delaney. We'll see you. See you guys.